the number of bits that we need. The number of bits that we need with this formula is a minimum is for example 3. Okay, that's it. This means that we need as a total 5 plus 3 8 bits for this requirement, and also we have 8 bits. Because of that, this 8 bit has a value less than 8 bits, less than or equal to the 8 bits of the original network. Because of that, we can do it. Okay, now we can start the designing of the IP address. 192.168.10/24 means 192.168.1, and all of these 8 bits now are the host bits. Okay, but we need only 5 bits for host, and we need 3 bits for the subnet. Let me to show you 192.168.1. Here we have 3 bits of subnets. This is our design, and also 5 bits of the host. You know that with this design we have 27 bits of the subnets and networks, because now these subnets are bits of the networks. You know it. Because of that, we need /27 subnet mask, and this means that this is equal to 255.255.255.224. That's it. Let me to design these networks. For triple S, we can create, with this triple S we can create 8 state: 000, 010, 001, okay, 001, then 010, then 011, then 100, 101, 110, 111, 8 format. Okay, if we use 000, this means that we have 192.168.1.000, then the host bits. Okay, for finding the network address, this is the network address, you know it. For finding the network address, we need to use the all of the host bits as 0. Let me to write here 50, because we have 3 bits of subnet and also 5 bits of host. Because of that, I'm using the 8 bits of 0. After that, here 192 for the next networks, 192.168.1.001, again 5 bits of subnets. And after that, here 192.168.1.010, again 5 bit of subnet. For the next networks, 192.168 for example 1, then 01150. After that, for the next networks, 192.168.1.100, again 50. And after that, for the next networks, 192.168.1.101, again 50. And after that, 192.168.1.110, okay, 50. And finally, look at here, 192.168.1.111, 50. That's it. If you want, you can convert these values to the decimal. Let me write /27. This means that 27 bits of this IP address are subnets. Okay, 27/27 /27, again /27, and finally /27. Now we can convert these IP addresses to decimal. This is the network address in decimal. 192.168, for example 10/27. That's it. After that, 192.168.1, look at here, this is the 32. If you calculate this value, you will find that this is equal to 32/27. After that, the next network address, 192.168.1.64/27. And after that, if you calculate the next network, is 192.168.196/27. And then 192.168, for example 128/27. And after that, 192.168.160/27. Okay, and after that, here we have 192.168.1.192/27, and finally 192.168.1.224/27. That's it. These are the network addresses that we have. Now, first we need to find the broadcast address. Let me write here the broadcast address. You know that for broadcast address, we need to use all of the host bits as 1. Let me write here. This is the, for example, broadcast address, if you want you can write first in the binary format. After that you can copy them, you can convert them to the for example decimal. The first broadcast address is 192.168.1.0.0.0, then 51. This is the first broadcast address /27. The second is 192.168.1.0.1.0.0.1, okay, then 11111/27, and after that the next net broadcast address 192.168.1 again 0.10.51/27. After that 192.168.1.0.1.1 again 51/27. After that 192.168 for example 1, then 100.51/27, and then 192.168.1.1.0.1 again 51/27, and after that 192, this is our design, 192.168.1.1.0.51/27, and after that 192.168.1.1.1.1 quad 51/27. That's it. You can convert these values to the decimal. Let me to convert them. 192.168.163/27. You know that 131/27. You know that the broadcast address has a one value less than the next network address. This is a shortcut. And after that, for the next broadcast address for the next networks, we have 192.168.163/27. After that, here we have 192.168.195/27. This is the 27. And then here 192.168.1 for example 127/27, and then here 192.168 for example 159/27, and after that 192.168.191/27, and finally 192.168.1.223/27, and the last broadcast address is 192.168.1.255/27. That's it. And you know that the host addresses are the addresses between the network address and broadcast address. Let me write here host address. Okay, here we have this value 192.168.1.1 to 192.168 for example 130. Let me write here 192.168.1.1 to 192, okay, 192.168.1.30. That's it. This is the range of the host address. Okay, this is the range of the host addresses. And here, let me to copy this value, and after that we can correct the values. Let me to copy them here. I will correct them here, here, and then. Let me to correct them. Look at here. The second network between the 33, okay, 33, one value more than the network, to the 62, one value less than the broadcast. The next networks here from 60, for example, 5 to the, for example, 94. That's it. And after that, the next networks from 97 to the 126. And here, as you can see, from the 129 to the, for example, 158. Okay. And after that, from the 161 to the last IP address is 190. And after that, in this network, we have 193. The host address starts from 193 to 222. And after that, in the last networks, we have 225 to, for example, 254. This is our design. You know that here we design 8 networks. In each network, we find the network address and also broadcast address. And you know that the addresses between the network address and also the broadcast address are the host address. You know it. Okay, these are the host addresses, and we can use them. In each network, we have 30 IP address, and this is same as our requirement, and this is good. But as you know, here we have 8 networks, but we need only 7 networks. You know that we need 7 rooms. In each room, we have 30 PCs. Okay, here we have 8 range. In each room we have, for example, 30 PCs. Because of that, we can use this range, this address, this network, okay, for the room 1, R1. This is for, or network 1, for example. Let me write here network 1. This is for network 2. This is for example, network 3. And this is for this range, means this network, okay, for the network 4 and 4. And here we have another network for network, for example, 5. Here we have another network for network 6. Here we have another network for network 7. And this is the spare range, okay? We can use this spare range for IP address assignment to the B requirement B. You know that in requirement of B, we need to assign the IP addresses in, we need to design the subnetting for 7 rooms. And in each room, we have 2 IP addresses. We need 2 IP addresses. Because of that, let me to use this range, okay, for the requirement B. This means that we need to start again for the subnetting for this requirement. In this requirement, we need to assign the IP addresses for 7 rooms. In each room, we have 2 VPC. Let me to use the requirement of the requirement F or A. And after some change, we can use it for requirement B. Look at requirement B. Here we have requirement B. We need, okay, 7 networks. In each networks, we have only 2 IP addresses. This means that 2 to the power of h minus 2 should be greater